For number 2, the diagram below shows masses on two motors in planes B and C. Determine the masses to be added on the rotor in planes A and D at radius of 40 millimeters, which will produce static and dynamic balance. So it's the same with the previous problem. We will find the mass, radius, MRX, angle, MRX cosine theta, MRX sine theta. So MA, it is not stated in the problem. For B, 5, C, the mass of the C is 3, and the D is not stated in the problem. So for the radius, A, the radius of this of the A is 40, and for B is 20, C is 50, D is 40. So for MR, in getting the MR is we will multiply the mass and the radius. So since there is no mass in A, we will copy the 40 for the MA. In B, the MR is 5 times 20 is equals to 100, and for C is 3 times 50 is equals to 150, and for D there is no mass, so copy 40. For the X, the distance is our reference is A, from A to B to C to D. We will start from A, 0, B 80, it is stated in the problem, 80, C is 150, D is 250. So for the MRX, we will multiply the MR and X. So MRX, so for A, 40 times 0 is equals to 0, 100 times, for B, 100 times 80 is equals to 8,000. For C is 150 times 150 is equals to 22,500. So for D, it's 40 times 250 is equals to 10,000. For the angle, the A is unknown, it is not stated in the problem. So for B is 45 degrees, C is 300 degrees, and how did we get the 300? So we get 300 because the whole center, the whole degree of the circle is 300. So I wrote 300. So for D, it is unknown, the angle is unknown. And for the next is MRX cosine theta, it is 0. And the 8,000 cosine 45 is 5,656.9. And for C is 22,500, and cosine 300, negative 11.250. And for D is 16,906.9. So it is the same with in number 1. We need to make it balance, we need to make it the result 0. So for D, there is no angle, unknown. We will assume a number that will make the result 0 to make it balance. So 5,656.9 plus negative 11.250, it is equals to negative 6,006.9. So we will assume a number to make it 0. So the same with the sine theta. We will assume a number to make it 0 to make it balance. So for the resultant, MRX for D is equals to 6,906 multiplied by itself plus 13,825.7 multiplied by itself, and the square root is equals to 21,842.07 kilogram millimeters. So the value for D, so 10,000, the here 10,000, the MRX for D is 10,000, and the resultant is 21,842.07 kilogram millimeter. So 21 to get the mass of the D is we will divide 21,842 times 0.07 divided by 10,000. So the result is 2.2 kilogram. So the mass of the D is 2.2 kilogram. So for the angle, the tangent 13,828.7 here, the sine, and divided by 16,906.9 is equals to 39 degrees. So the true angle is the whole angle is 180. Since it is clockwise, so we will minus it, we will diminish it. 180 degrees minus 39, the angle is equals to 141 degrees. So the angle for the A is 141 degrees and the mass is 2.2 kilogram. So it's now for D, I'm sorry. For D, the mass of the letter D, of the D is 2.2 kilogram and the angle for D is 141 degrees. So now we will find the mass and the angle for letter A. So it is the same process. We will make first table to find the mass and the angle of the A. So MA, there's no stated in the problem. The radius is 40, for B is 20, C 50, D 40, and for MR, multiply mass and radius. There is no mass. Copy 40, 5 times 20, 100, 3 times 50, 150, and the mass, since the mass of the D is 2.2, we will now put the 2.2 mass in the D. So 2.2 times 40 is equals to 85. So in angle, the A is still unknown. So in B, 45 degrees. In C, 300 degrees. In D, we got the angle for D. So we will put it in next table for A. In D, 141 degrees. And for cosine, for A, we will assume it to make it balance, to make it 0. So we will proceed to B, 70.71. So C 75, and for D is negative 68.39. And the same with sine. The process here is the unknown angle for A is, we will assume a number 2, make the result of this B, C, and D to make it balance and 0. To make it balance and the result is 0. So the resultant is MR vector equals to 77.32 multiplied by itself plus 3.82 divided by itself, square root is equals to 77.41 kilogram millimeters. So the value for A is 77.4 kilogram millimeters divided by 40. Here the MR 40 is equals to 1.9 kilogram. For the mass for A is 1.9 kilograms. So in getting the angle for A is, we will the tangent negative 1, 3.81. Here 3.81 divided by 77.32. We will now make it positive in writing here. 3.81 divided by 77.32 is equals to 2.82 degrees. So the true angle is since the whole angle is 180 degree and the reading is clockwise, so we will minus it, we will diminish it to 3. 180 degrees minus 282 or 3 degrees is equals to 177 degrees. So the mass for A is 1.9 kilogram and the angle for A is 177 clockwise, 177 degrees clockwise. So that is how I get our activity. So thank you.